Week 8, solve exponential growth and decay notes. For this week, you are going to need a calculator that has exponents or can do exponents. So on the TIs, if I wanted to do 2 to the 10th power, to get an exponent, it's right above this division bar. I can use this up arrow and I can type in 10 and then hit enter. Now I've made a video about some other options in case you don't have those calculators, but here is one of the other options. If you have an iPhone or an Android, when you tilt your phone the other direction, it will give you some more options. So if I'm doing 2 to the 10th power, look for this x to the y value, and I believe it's the same thing on the iPhones. I would plug it in just like this. That up arrow means that this is an exponent, and I hit enter. There's my answer. So you can use your phones on this assignment. Now we are also going to have to round because when we are dealing with money, we are going to round to the hundredths place, which is 2 decimals. And when we're talking about people or other things like cars, cell phones, things like that that don't make sense to be a decimal, we are going to round to a whole number. Okay, so let's go through example 1. It says the value of an antique vase was $200 and is increasing at a rate of 8% each year. So write an exponential function to model the situation, then find the value of the vase in 10 years. So we need to identify A, R, and T, and then we can use this formula for exponential growth. I do know it's growth because they said it's increasing, so it's 1 plus the rate, not a minus sign. Now, A is the beginning amount. That's how much the vase started off as being worth $200. For the rate, they said 8%. Now, remember, when you are dealing with percentages, to use them in this problem, you've got to change this to a decimal. So I would do 8 divided by 100, which is just this. 0.08, and that's the number that I am actually going to use for my R value. Okay. Now the last one, T, this is the first time we're going to plug in a value for that. T is talking about time. Well, they said 10 years, so that means T is 10. So all I need to do now is plug this into my equation. So I've got Y is equal to 200 times 1 plus my rate of 0.08 to the 10th power. I want to go ahead and simplify this. So I have y equals 200 times 1.08 to the 10th power. And now we are going to plug this into our calculators. So if I do 200 times 1.08, I raise this to the 10th power. I can type it in exactly like it looks. Don't worry about the y equals part. And that gives me this. So I've got 431.7849, and I'll stop there. Now, since this problem is talking about money, it makes the most sense to round to 2 decimal places. So 431.7 is definitely going to be there. Now, this either stays an 8 or goes up as a 9. Because the number right after it is below 5, this one stays as an 8. So there's my answer. When you enter this onto Canvas, do not worry about putting labels like the dollar signs or anything like that. Now, I'm also going to show you how you would plug this one in on your phone if you're using that. I can still type it in the same way that we had right up here. I have 200 close it. Then I am doing the x to the y value to get my exponent, and I can plug in 10 right there, close that parenthesis, hit enter. And you can see it is the same answer that we got using the other calculator. Okay, let's do example 2. The number of employees at a certain company is increasing at a rate of 3.25%. In 1976, there were 1,440 employees. Write an exponential function to model the situation. Then find the number of employees that would work there in 1989. Okay, so we do have a little bit more we're going to have to do to this one. Since we're talking about the number of employees, the number that they started off with was 1,440. Now the rate they said was increasing, so we are doing growth again. We need a plus sign. Now that was 3.25%. And before I can use it, I've got to take the 3.25 and divide it by 100, which gives me 0.0325. Now, the other thing that we are going to have to do is to figure out our t value this time, because they didn't straight up tell us how many years, but they did tell us that the beginning was in 1976, and we're trying to figure out how many there would be in 1989. So if I want to know how many years have gone by, I would do 1989 minus 1976 to figure out exactly how many years that's been. If I do that, I've got 13 years. So 13 would be my t-value. Okay. So now let's plug this into the formula. Y is equal to, my a value goes first, that's 1,440. Then I've got 1 plus the rate, which remember you're using this one over here. And then this is being raised to the 13th power. Now I always like to make sure that I simplify whatever is inside the parentheses before I start trying to plug things into my calculator. But now that I have it written just like that, I can type it in just like it looks, parentheses and all. And I'm raising it to the 13th power. When I hit enter, I got 2182.39459. Okay, we need to think about how we are going to round this one. Since we are talking about employees, it doesn't make sense to have 0.39 employees, so we are going to round to a whole number. This would be 2,182 people. And remember, you are not going to enter in the labels when you put it on Canvas. Now, here's how I left it as a 2, because the number right after that decimal is a number that's okay. Let's look up at example 3. It says a new car is worth $30,000 and its value depreciates 15% each year. Depreciates means it's decreasing. So write an exponential function to model the situation, then determine how much it would be worth in 5 years. Okay, so I know that this car starts off as $30,000. That's my A value, the beginning amount. It's depreciating by 15% each year. So I need to make sure that I do that 15 divided by 100, or you can just move the decimals, but that would give me 0.15. And this time they actually told us how many years, so we don't have to do any subtraction or anything. We can just put 5 right there. So that means y is equal to 30,000 times 1 minus my rate, which is 0.15, and that's being raised to the 5th power. So all I did was plug in that a value, my r value right there, and my t value in place of 5. So I always like to double check when I'm simplifying inside my parentheses, just to make sure that the subtraction is done right. That gives me 0.85. So that's y is equal to 30,000 times 0.85 to the 5th power. Okay, so let's plug that in. We've got 30, 1, 2, 3, 4. Make sure you have the right number of zeros in there. Double check yourself. And this is being raised to the 5th power. When I hit enter, I got this. So that is 13311.15938. Since with this time we are talking about money, it makes more sense to leave it as 2 decimal places. So I'm going to put 13,311.16. The 5 went up a number because the one right after it was bigger than 5. Last example. In 1995, the population of a small Midwestern town was 4,500 people. The population has been decreasing at a rate of 1.5% each year. So write an exponential function to model the situation, then determine what the population would be in 2020. Now, they said decreasing, which is why I wrote the exponential decay function with the minus sign. My a value is the original amount. Well, we're talking about population here, so they said they started off with 4,500 people in 1995. Now, the rate is 1.5%, and a lot of people are tempted to use 0.15, but that is not correct. So make sure that you actually do 1.5 divided by 100 to see what it gives you. And that would be 0.015. Now, T is talking about the time in years. This time they didn't tell us how many years, but they did tell us that we're going from 2020, or that's the later year, and it started off, excuse me, I was letting that unfreeze. So it started in 1995, and we're seeing how far that was to 2020. So I do 2020 minus 1995 to see how many years that is. and that should be 25. Which means our t-value is 25, and now we can plug it into the formula. So y is equal to 4,500 times 1 minus the rate, which we said was 0.015, and this is being raised to the 25th power. Now, I highly recommend that you subtract inside those parentheses. When I do that, and look what I did. I did not put my 0. Watch out for that. That would have given me the wrong answer. 0.015, hit enter, and you've got 0.985. And now that I've got my equation, I can just type it into the calculator to get my answer. And like I said, be very careful with the way that you type those in. It's very easy to make a silly mistake when you're typing it in. So I ended up with 3084.027743. Okay. Now this one is once again talking about people, and it doesn't make sense to have like 0.02 people, so we're going to round to a whole number. Since we've got 4 followed by a 0, the 4 is not going to change, so it is 3,084 people. Please remember, do not put any labels in whenever you enter your answers on Canvas.